we've looked at some simulations and we've looked at some demos about all these different properties of gases. We've had pressure and volume and number of moles and temperature.
Right.
There is actually one equation where we can take all of those things and jam them all together.
Of course there is.
Yes. So we can look at what happens when pressure changes, when volume changes, temperature changes, all of those things. But the nice thing is we can actually only use one equation and just take things out when we need them, when we don't need them.
Ooh.
So yeah.
I like one.
So it looks really scary right now because there's 8 things we've got to plug in, but most of the time we're going to be plugging in maybe 3 or 4. So
all right.
The biggest thing we need to know first is what we're actually going to be plugging in. So first of all, we've got P. So which property of gases do you think P is?
I'm going to go out on a limb and say it's pressure.
Yep. So P is pressure. V is going to be?
Volume.
Okay. N is going to be the weird one.
Okay.
N's a number of something. Number of moles. Number of moles. And the nice thing is, this is really just telling us the amount of gas, but it'll be in terms of number of moles.
Okay.
And then T is going to be, what do you think?
Temperature.
Temperature.
Okay.
All right, now.
Sorry, ladies and gentlemen.
Sure.
Thank you. I turned off the spell check on my hand. So.
Yes. So we're gonna start at the bottom and work our way up for units you're looking for to know if you've got these things.
Okay.
So temperature and number of moles are our easiest because there's only ever one choice.
Okay, good.
Temperature always has to be in Kelvin.
Okay.
And so Kelvin is a special temperature scale that you should have been talking about already, but we'll go back and talk about that a little in a second. Number of moles is always going to be in, what do you think?
Moles.
Moles.
M-O-L.
Yeah.
Right?
If you've got moles, it's N.
Okay.
All right.
That's nice.
Right. Volume can be a touch more complicated, but not much. Volume, because we're scientists, we use metric. Volume will always either be liters, which is L, or milliliters, ML.
Okay, that makes sense.
I don't think we're going to have any cubic centimeters one, but you might. All right, and then pressure. Pressure gets a little weirder. Pressure, you have several options, but they're not really any different. Okay. Pressure can be in ATM, atmospheres.
ATM, all right.
It can be in mmHg, that's millimeters of mercury, which is literally based on the millimeters of mercury in a column. Yeah. It can be in torr, which funnily enough is mathematically exactly the same as millimeters of mercury. They just gave it a special name. Or it can be in kPa.
kPa.
Which is kilopascals. So if it's any one of those 4 things...
Better ask the pascals before you do that.
It's going to be pressure. Everything else, pretty easy to recognize. So overall, if you're not sure what it is, it's probably a pressure unit.
Oh, okay, that makes sense.
Yeah.
I'm just going to add, I didn't add that in there.
Yes,
so
Kelvin
it's just
is K.
Okay.
Yeah.
Very cool.
All right, so let us look at a problem where we're using this.
Oop.
All right, so here, it tells us the pressure of a gas is 275 millimeters of mercury when it's confined in a 2.5 liter container. What would be the volume of the gas if the pressure is increased to 800 millimeters of mercury? So our best first step is to always identify what we have, what we're given, and what we want to find.
Okay.
Because we've got so many letters to keep track of, it's really nice, though, to make a list with what the letters are. So what's the first thing it tells us?
The first one it says is pressure of a gas is 275 millimeters of mercury.
So if you go back and look at the equation you just wrote down, you notice that we've got P1 and V1 and N1 and T1, and then we've got everything else with a 2.
That's right.
This is because we're going to start out in one condition and change some stuff. So you've got to make sure you mark your beginning as 1 and your ending is 2, because you're going to end up with multiple pressures, multiple volumes, depending on what kind of problem you're doing.
Okay.
So it's telling us the beginning, so this is going to be our pressure.
So this is the
1.
First one. All right.
And so what's the next thing it tells us?
When it is confined in a 2.5 liter container, so that would be the volume.
That's the volume, and that's our volume at the beginning, so that's our V1.
Okay. 2.50 liters.
And we know that's a volume because it's liters.
Okay.
Now, what's the next thing it tells us?
What would be the volume of the gas if the pressure is increased to 800 millimeters of mercury?
So what's the last other thing it tells us?
So the other thing, it tells us that the pressure changed. It went up. So that would be the 2?
Yeah,
the
that would be our
P2?
P2.
Okay. P2 equals 800 millimeters of mercury.
All right.
Okay.
And so then what's the other thing it's asking about?
It's asking for the volume. If we change the pressure, so then that's going to be the V2.
Which is what we're going to be looking for.
Okay.
All right. So now let's look at our equation real quick. We know
Okay.
we've got P1 V1 over N1 T1 equals P2 V2 over N2 T2. Yes, it sounds like we're listing off Star Wars robots. All right, but look at what we know versus our equation. So what actually shows up?
All right. We know P1 and V1
What else do we know?
and P2.
And what are we looking for?
And we want V2.
So what never, ever, ever shows up?
We did not include N1 and N1 or N2, nor did we include the T's, T1 or T2.
So if it never mentions it or it tells you it's constant, you can cross it out of your equation. So let's cross out all of the bottom. We don't care because it never came up. So what does that really leave us for doing our math?
Well, that just leaves P1 V1 equals P2 V2.
Right. So now what we're going to do is plug in what we know and do some algebra.
Okay.
So now we just said we were going to do P1, which is our
275,
times our V1
which is the 2.5,
equals our P2
which is 800,
times our V2.
which we don't know.
So we're just going to put our... All right, this is a good time to remind you. Leave the variables like they are. Don't always change your unknowns to X. It makes your life so much harder because you don't remember what you're looking for. Just plug in V if you're looking for V. All right, so now to do our algebra, what are we going to have to do? How are we going to get V2 by itself?
So we're gonna, let's see, where you need to multiply 275 times 2.5. So I got 687.5 equals 800 times V2.
Okay, and so now how do we get V2 by itself?
We're going to have to divide.
Divide by 800. Yep.
Divided by 800 gives us 0.8. I've got 0.859. Can I go ahead and just make
Round
that
to two decimal
0.86?
places. Yep.
All right. 0.86. We wanted volume, so it's in liters.
Right. So your volume 1 units should match your volume 2 units if that's what you're looking for.
Okay.
Because your MMHD you're going to cancel out.
Okay.
All right.
So when we increase the pressure, the new volume is 0.86 liters.
So does that make sense with what we've talked about already with gases? So we took our pressure was 275, it's now 800, so did it go up or down?
The pressure went up.
Pressure went up, so what
And
should our volume have done?
Volume went down because the gas particles are getting squeezed.
Right.
Closer.
So you add more pressure, your particles get squished closer together,
Okay, and
so
so
your
they're taking
volume
up less space.
should
All right,
decrease.
so then, yeah, it did what it was supposed to. Okay, very good.
Yeah. All right, let's
All
try
right.
another one.
Okay, so if I initially have a gas at a pressure of 12 atmospheres.
And remember, this is our starting, so it should be P what?
P1. Oh, okay, because it said initially, so that's at the beginning. A volume of 23 liters, so that's V1 is 23 liters. And a temperature, that's going to be T1 of 200 K, that Kelvin that you said we have to use. And then I raise the temperature, I raise the pressure to 14 atmospheres. So that's P2. That's the second pressure. Okay, 14 atmospheres. And increase the temperature, so that means that's T2, judgment day, or 300 Kelvin.
300 Kelvin, yep.
Sorry. What is the new volume of the gas? So we want the new volume.
Right.
Okay.
So, we've got a lot of stuff here.
Mm-hmm.
But what do you notice has never ever showed up?
Net N didn't show up at all.
N didn't show up at all.
Yeah.
So you can take your original equation.
Okay. Okay.
And
Oh no.
P1 over V1
There we
equals
go.
P, yeah, N2
One.
and 1. Yeah, everything. 1s are all on the left, 2s are all on the right.
And 2. T2.
Okay, so what never ever showed up?
N didn't show up.
So we can just cross out our N.
We can take it out.
Yep, N's gone away. So that just leaves us PV over T equals PV over T.
Okay.
So now we plug everything in and we do algebra.
So now I just fill in.
Plug it all in. So we had our pressure.
Pressure was
12,
12
times our volume.
times the volume, which was
23.
23
Over our temperature.
over the temperature, which was 200,
Mhm.
equals the new pressure, which was 14,
times.
times the volume, the new
Mhm.
volume, that's what we're looking for,
Mhm.
over the new temperature, which is 300.
Now, some of you have been waiting a very long time for this. A bunch of you in dimensional analysis were like, but we should cross multiply divide. Now you actually do. The time has come. We can cross multiply and divide. So we're
Awesome.
going to have 300
Okay, we're going to have 300.
times 12 times 23.
So all of that,
And then you're going to multiply 200 times 14 times V.
and then those.
And so let's do that. Let's do the math
Okay.
first. All right. So we did our cross multiplying, but not our dividing yet. So our cross
Okay.
multiplying is 82,800.
82,800 divided by.
No, we're not dividing yet.
No.
Equals 2,800 V.
Okay. I got excited. 100 V.
All right. So we've cross multiplied. Now
Okay,
we're
now we
going to
want
divide.
to divide.
Yeah.
2,800 on both sides.
V is now 29.57. And what were our volume units before?
Liters.
So they're still liters. All right. And this one's a lot harder to logic check because there's a lot more going on. So we're not going to worry as much about this.
Okay. Couple problems for guided practice.
Mhm.
They're similar to these. Pause the video if you can. Try it on your own, and then come back and check and see how you did.
So overall, figure out what your variables are, plug them in, do your algebra. That's pretty much all of gas laws. All right. Come back and see us when you're done.